So this session is going to be on average velocity, and I am going to help you with some tips for problem solving in the concept of average velocity. Now, what is given in this problem will be history of journey of the history of the journey given in multiple segments. They talk about different segments of the journey of the body, and they give you some relevant necessary parameters connected with that, and it is for the students to calculate the average velocity. Now, what are the interrelated parameters? Distance is one of them in that particular segment under study. Time, duration of the journey for that particular interval, not the whole journey, but velocity for that particular segment. And then with all the given data, to determine the average velocity from the data given will be our study that we are taking up now. I am going to take out different situations where there can be variety of the data given, and how we go ahead to find out the average velocity. After we give the tips, we can take some numerical examples and solve them. Now, supposing the problem says, I'll first do it with some numerical example. See here, the problem says, in the first part of the journey, for the first, say, 4 seconds, its velocity is 3 meters per second. Next, that is second 5 seconds, the velocity is 4 meters per second. And the next third, that is third 6 seconds, its velocity is 5 meters per second. Let us say that this is going to be the data that is given. So here, what are the values that are given? T1 equal to 4, T2 equal to 5, T3 equal to 6. V1 equal to 3 seconds, this is seconds, and this is seconds. Now V1 equal to 3 meters per second, V2 is given to be 4 meters per second, and V3 is given to be 5 meters per second. Then S1 not given, so I am putting a question mark. S2 not given, question mark. S3 not given, question mark. So it is for the student to find out S1, S2, S3 from informations of V1 T1, V2 T2, and V3 T3. Then total T is also not given as a question mark. Anyhow, the student can find out total T using T1, T2, and T3 informations. So how do we go? Therefore, V average is equal to question mark. That is the problem. Now, how do we proceed? Will be our next question. Now, we can even write it in a tabular column. Now, I'll explain to you about the independent variables. In a problem. Now, if you have a tabular column like this, they're telling the history of motion for the 3 segments that we are taking as example. Serial number, the parameter, and the 3 intervals. One is your S in meters. So for the first segment, let us call it as S1. For the second segment, let us call it as S2. And the third segment, let us call it as S3. And then and here you can have total. Then the second one will be total of distance will be equal to S1 plus S2 plus S3. And then here your parameter is S. Then T, time, in seconds. That is T1, T2, T3. Total will be T equal to, this is equal to capital S. T equal to T1 plus T2 plus T3. Then 3, velocity, meter per second. Here it is V1, here it is V2, and here it is V3. It is not applicable here. You cannot find the total velocity. Not applicable. Nor relevant. So the question of total of the entries will be significant only for the total distance and the total time, and not for the velocity. Now here if you analyze this tabular column, you have got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 variables are there, out of which this one S1, T1, V1 are interrelated, S2, V2, T2 are interrelated, S3, T3, V3 are interrelated. So they cannot be considered as 3 independent variables, because any 2 being given, the other one is automatically a function of the other 2. So of the 6 variables, the problem has to give 6 independent variables. Very important, 6 independent variables. They cannot give 1, 2, 3 in the same vertical row, S1, T1, V1. No matter, even if they have calculated it correctly, those 3 cannot be considered as 3 informations. Even if they have given 3 superfluously, effectively it means they have given only 2 in this. Likewise here if they have given 3, it means they have only given 2. So that makes it effectively only 4 independent variables being given, so 2 more remain for the third one of them. So that is what I meant by 6 independent variables. Now that is the concept of independent variables. Having said this, now for our particular problem, how are we going to proceed and fill up the tabular column? Here, in this case, they have told, let us take the data once again. V1 is 3 and T1 is 4. So V1 equal to 3 meter per second, T1 equal to 4 seconds. Therefore, S1 is equal to V1 T1 equal to 3 into 4 equal to 12 meters. This is for the first one. The second one, V2 equal to the 4 meter per second, and T2 is 5 seconds. 4 and 5. V2 is 4 and T2 is 5. V2 is 4 meter per second. And T2 is 5 seconds. Therefore, S2 will be equal to V2 T2 equal to 4 into 5 equal to 20 meter. Then third one, V3 and T3. V3 is 5 and T3 is 6. So S3 will be V3 into T3 equal to 5 into 6 equal to 30 meters. So S1 is, this is S1, this is S2, and this is this thing. So S total will be equal to S1 plus S2 plus S3 equal to 12 plus 20 plus 30. That is equal to 62. For 32, 62. Then T total will be equal to T1 plus T2 plus T3 equal to 4 for T1 and 5 for T2. This is, I'll put another circle here for T. And then T2 is 5 and then T3 is 6. 4 plus 5 plus 6. 4 here the T2 is 5 and then T1 is 4. 4 plus 5 plus 6 equal to 15 seconds. So having got these two, S and T, V average will be calculated as, so V average will be S total by T total for the given problem, which is 62 meters by 15 seconds equal to 15 fours are 60 and 2 by 15 meter per second. That is how we calculate the average value. Then second situation, this is first situation. There in the previous problem, neither of the velocities V1, V2, V3 were equal. Neither of the time intervals T1, T2, T3 were equal. Now in the second case, we are going to have equal time intervals but different velocities. So different distances. So what is the flashing hint of this? T1 equal to T2 equal to T3 for the three segments under study will be equal to capital T by 3. Each is 1/3 of the total time. Because T1 plus T2 plus T3 should be equal to T, or 3T should be equal to capital T, or small t will be T by 3. But V1 not equal to V2, not equal to V3, and so we have to take, we cannot write it. Now S1 not equal to S2, not equal to S3. And your question marks are S1 question, S2 question, S3 question. Okay. Now let us use the algebraic connotation and see if we get a simplified expression before we go into the actual numerical value proper. Now S1 is equal to V1 into T, T1 equal to V1 into T. The suffix gets dropped because T1 equal to T2 equal to T3 equal to say T. All of them, they don't have, the suffixes will be significant only if they are going to be different. If all T1 is going to be T2 equal to T3, we just drop the suffix and just write V1T. S2 equal to V2 T2, which is V2T. S3 equal to V3 T3 equal to V3T. Therefore, you have capital S will be equal to S1 plus S2 plus S3. That is equal to V1T plus V2T plus V3T equal to V1 plus V2 plus V3 times the interval, 1/3 of the total time. That is equal to, now T is equal to T plus T plus T, T1 plus T2 plus T3 as in general case, as in previous example, now it will be t plus t plus t equal to 3t. Therefore, V average will be equal to S divided by T equal to V1 plus V2 plus V3 into T by T plus P3 plus, which is 3T. That will be equal to T and T will get cancelled. Simply V1 plus V2 plus V3 by 3. It is as if you have got 3 entries and you take the average like any other average. You just add all the given values and divide it by the number of entries. It will be as simple. That's why earlier I told you V average is not equal to V1 plus V2 plus V3 by the number of entries in general cases necessarily. But it may so happen that it is the average of all the entries here, as in the example of equal time intervals. The next session will be when you space it to be equal distance intervals and the timings are different.